I will talk about the analytical and microscopy group, and it's only a general introduction. So the analytical and microscopy group has 27 labs. I don't know how much, I didn't count the equipment, but it's each lab has more than one equipment. 17 partners from 7 countries. These are the countries, the partner countries, Spain with 8 labs, Portugal with 3, Italy with 2, and the Netherlands with Germany and Switzerland and UK with 1 lab. This group provides harmonized laboratory data, contributing to the TCS repositories. It also has a local repository and a general repository for data storage and the TCS metadata editor. The group also provides transnational access to the facilities, to the labs and equipment. This group by itself goes from, we can say that it goes from macro to micro and even nanoscale studies. From macro, rock sample, which is always a bit of a large outcrop. When the outcrop is homogeneous, we don't have to do many samples to have many rock samples, but if the outcrop is varies, the sampling we must have more samples. So when we to perform analytical studies, we always have to use microscopy to choose the samples which will be analyzed. So for that we use the microscope, normal microscope. Here are 2 examples of the view on the microscope on thin sections. Here is with the object 6.3 objective, here with a more magnifier objective. We have the fluid inclusion studies, which go from micro and even sometimes for nanoscales. Here 2 examples of biphasic and triphasic fluid inclusions, and also the study of zircons for geochronological for studies. So it goes from large scale to micro and nanoscale. These are the list of the laboratories that participate in this group. As you can see, it ranges all the analytical equipment to perform studies. These are some of the equipments. Goes from X-ray diffraction, X-ray fluorescence. These only analyze all rock. Then we have equipment for micro analysis, like the electron probe microanalyzers and SIMS, micro thermometric labs, Raman microspectry analysis, and scanning electron microscopy, which is many times together with other type of equipment. The ones that are in blue are the ones that can obtain images. So this equipment is the support for geochemistry studies. That means to obtain the oxide, major, trace, and isotopes. For environmental geochemistry and hydrogeochemistry, isotope geochemistry, geochronology, geothermal barometry, mineralogy and mineral chemistry, fluid inclusion studies, and imaging. Going from geochemistry, which is applied to macro samples or representative of macro, to micro or even nano. This kind of studies are the support of the petrology, volcanology, sedimentology, and hydrogeology. And those disciplines are applied to geological and mineral resources, among others. Here are only some of the applications: magmatic hydrothermal systems characterization, prospect and research of mineral deposits, mineral exploration and mining operations, CO2 geological storage, gas, oil and reservoir management, geothermal prospection and exploitation, climatology and paleoclimatology. Of course, that some of these studies require other disciplines also to be completed. Here is an aspect of imaging that can be done with a microprobe, with microprobes. This was an experience made by my colleague, Fernanda Guimarães. You can see image obtained in at 15 kilovolts and at 6 kilovolts, and you can see that even with a lower kilovoltage, the imaging result is better than the one with the 15 kilovolts. This is very good for the distribution of elements in minerals. As you can see, I have the magnesium, niobium, ferro, and iron and titanium. This is another example of the application. This is with a microprobe. You can draw perfil, how do you say, with the composition along this line. And the varies for magnesium, zirconium, titanium, iron, and niobium. This was an experiment made by my colleague about the variation on these elements. Finally, just to show you one application of this kind of studies. This was done in Fogo Island eruption. This is wrong. This is 2015, 2000. should be 16, 14, 16, sorry. So this was where we collected the samples of the eruption, and we studied not only the composition of lavas, but also composition of the nodules included in the lavas. We wanted to see if they were cumulates or if they were xenolites from the mantle. Unfortunately, they were, yeah, the nodules, they are small nodules. Unfortunately, they turned out to be only cumulates. So we analyzed all the minerals. And we performed geothermal calculations to see the point of crystallization for clinopyroxenes. The results were not very conclusive, but we were able to constrain the depths of formation by founding the pressure of crystallization and the temperature of crystallization for the various analyzed nodules.